to the Quantum Feedback Loop podcast. I'm your host, James Myers, and I also publish the Quantum Record, which features the latest in science and technology. Why do animals communicate? And why and how did their many different methods of communication evolve? It was fascinating to learn from Dr. Arik Kershenbaum so much about such a crucial part of everyday living in the animal kingdom, one until now that I've rarely thought about in my own everyday life. Arik is a zoologist and fellow at Girton College, University of Cambridge, where he studies vocal communications in animals, including wolves, dolphins, and gibbons. Arik's 2021 book, The Zoologist's Guide to the Galaxy, takes us on a journey through the incredible variety of animals and their communication here on Earth and, possibly, beyond this planet. And I'm looking forward to what's in store in his new book, Why Animals Talk, which is coming out this August. We're seeing a whole new realm when we understand that animals are, as Arik says, not just automata, but living species with communicative intelligence not unlike our own. So animals may communicate on a different level with different limits, but there's a whole realm of information being exchanged out there in nature that I'll appreciate far more deeply the next time I hear a bird singing, a dog barking, or the chattering of a squirrel. So here's my conversation with Dr. Arik Kershenbaum. Welcome, Arik, to the Quantum Feedback Loop. I think our listeners are going to be really interested in learning about the science of animal communication.
Thank you. Thank you for inviting me.
Well, I'm looking forward to the release of your new book this August, Why Animals Talk. Can you give us a preview of the many forms of animal communication that you discuss in the book?
Yeah, so all animals communicate. It's just what animals are. It's part of the nature of animals. They move, and if you move, you communicate because you're not next to the people you were next to before. So communication is absolutely fundamental. But obviously, there are animals that communicate very simply, and there are animals that communicate in a more complex way, all the way up to animals such as ourselves that have language and can write books and plays and podcasts and things like that. So what's really interesting is where this complexity is, which animals have it, which ones don't, what are the different kinds of complexity. There are many different kinds of complexity in communication, and where it comes from. The book's called Why Animals Talk deliberately. It's not how animals talk or what animals say. It's about where this comes from, where this complex communication comes from. Why do they need it? Why have they evolved it? What are the different sort of social structures and interactions that make complex communication advantageous?
It's essentially a survival mechanism, I think, from, as I understand from your first book.
So it certainly gives an advantage. I mean, these are traits that are evolutionarily advantageous, and they spread and they pop up again and again because they are so advantageous. You know, there are the evolutionary origin of complex communication is spread across the animal kingdom. You know, complex communication has evolved many times independently. It is incredibly useful, particularly when you live in groups. You know, those animals that live in societies interacting all the time with other animals of their group, somehow information has to be transferred. And the way it's done is very specific to those particular animals and the particular environment they live in. But that need to convey information within a group, within a society, is very fundamental.
We humans tend to think of communication as being primarily visual, verbal. I mean, I guess that's kind of our daily experience, but I know you've written about many different types of communication, some types that we don't really think of, like smell, for example, like chemical communication. What are some of the most surprising or interesting types of communication have you encountered in your research?
Well, there are many different modalities, many different channels along which communication can take place. And as you say, smell is the obvious one. It's the oldest form of communication. It really goes back even long before animals evolved. Um, but it's very simple. Smell cannot really contain a lot of information. So where you start getting complex societies, complex interactions between animals, then a more reliable, a deeper, richer communication channel is needed. And obviously we're very used to sound. Sound is the one that we use most of the time, and vision as well. And they're really good. You know, they're really good ways to communicate. There are some other ways around and about. You know, there are less commonly used communication channels. Electric fields, for instance, can contain a lot of information, but they're really uncommon. On our planet, we find very few species that use electric fields for communication. We find many, many, many species that use sound and sight. for communication. And this is really just a constraint of the physics of how these different forms of conveying information work. Electricity is very expensive for anyone who's just got their utility bill. And it's expensive evolutionarily as well. It takes a lot of energy, whereas to generate sound is considerably easier.
What do the different types of communication tell us about the processes of natural adaptation? I guess these different animals are living in different environments, different media through which they communicate. Over time, I guess, is there any interesting examples over time of a way that a particular animal's communication has changed in response to the changes in its natural environment?
We can look over deeper time and look at how different communication strategies have evolved, sort of going from simpler and becoming more complex if it's beneficial for them to be more complex. But we can also look in quite short time. So a very common example that we see all around us is changes in bird song as a result of urban noise pollution. So birds that have evolved to communicate using song at particular frequencies and then find themselves very suddenly, from an evolutionary perspective, in an environment with all this car noise and car horns honking and is really masking a lot of their sound. And then it becomes very advantageous to change the frequencies at which they sing so that they can overcome these obstacles. So where you have communication that's really important, and birdsong is really important to birds, it's how they define their territory and attract mates. Where it's a real advantage to be able to communicate, you'll see very rapid adaptation if that communication is disrupted.
That's interesting. And I'm wondering how our human activity, I guess, has, I mean, I guess, does that change in the birdsong particularly disrupt the way that they interact with each other? Or was it are they able to now interact in the same way as before, just on a different frequency? Or has human activity fundamentally changed the nature or the outcomes of animal communication?
Yeah, in any complex system, it's very difficult to change one little thing and expect nothing else to change,
Mm,
right? Everything
mm.
is very closely related. And certainly when you look at birds in an urban environment, it's so different in every way from the environment in which they originally evolved. So no, it can't possibly be just the case of, well, we'll change our song a little bit and everything's back to normal. No, the environment they live in, buildings instead of trees, there's kinds of foods that are available. Everything has changed. And when you get this very, very rapid change in the environment, you get very rapid change in every aspect of animal behavior. Many of these things we don't really understand very well. It's actually quite difficult to quantify just how much effect we have had on many of these species. But the fact that we've had a big effect is pretty clear.
Do you think that the animals are talking about us?
So there are some examples, not many, remarkably few, where we can clearly see that animal communication is at least in part aimed at conveying information about the surroundings. What's around? Predators, food, and so on. Most of the time, that's not the case. So for most animals, communication is not about other things. It's about defining your territory. It's about attracting mates. It's about perhaps warning other individuals of your species to not to approach and so on. Dominance interactions and asserting dominance. There are examples. There are many examples, but not an overwhelming number, where animals communicate about other things. What kind of predator is around? Is it a snake? Is it a leopard? Where can we find food? Where should we go and forage for food? And of course, we fit into that natural environment as predators. So there are cases where animals will say, essentially say, look, there's a human, run away. But it's interesting that these examples are relatively rare. Relatively rare. Most of the time, most of these animals aren't talking about or aren't attempting to describe the outside world in the way that we find very natural. We find very natural about communication is to describe what we see.
Mm. That's interesting. And what do you think that a greater understanding of animal communication, like if we were really able to decipher a conversation among animals, what do you think that would do to our relationship with our human relationship with animals?
I think that communication will always, in any species, um, tell us something about cognition, tell us something about what those thought processes are and what depth of thought processes are available. So if you talk about translating or interpreting, which may not be the greatest term, but if you think about birdsong, come back to the simple example, uh, that's easy to translate. Okay, this is my territory. If you're a male, stay away. If you're a female, come and mate with me. So we do know very much what the birds are saying. And that gives us an insight into the kinds of mental processes that those birds have. Um, there are many other species where the interactions, these sort of dominance interactions, are a little bit more complex, and they tell us something about the way those individual animals interact with other individuals of their own species. If you think about wolves, for instance, the communicative interaction between wolves that really sets the sort of the dominant structure of a group. It tells us a lot about those mental processes. The animals are thinking about dominance. They're thinking about what is my relationship with this other individual? Should I approach them? Should I not approach them? Should I be scared? Should I be pleased to see them? So by looking at communication, gives us a window into the animal's thought processes in a way that we can't do in any other way. And of course, the communication becomes more and more complex, we see more and more complexity in those cognitive processes until you get to, for instance, looking at chimpanzee communication, which really is very complex because those chimpanzees live in very complex social groups. And there's been wonderful work on understanding what those animals are thinking, how they're thinking, what those cognitive processes are like from looking at the depth of the communication that they express.
Hmm. And so we're maybe learning more about ourselves, our own cognitive processes, maybe by contrast or comparison to what we're observing in animals.
That's a really difficult one. That's
Yeah.
a really difficult one to address because the fact is we don't really know how we got where we are. So sometime in the last 6 million years, when our ancestors diverged from the ancestors of modern chimpanzees, somehow along the way, we evolved the ability to speak in a language. And we don't really know when that was or how that happened. And it was such a major change that it's really hard to draw direct parallels between what we can do, what the two of us are doing now, and what chimpanzees or dolphins or wolves or bees do in terms of communication. So it's difficult to look at animal communication and say, well, this is the direct precursor of our own language. But if you do look at those animals that have complex communication and you look at how that reflects their social needs, that does give us clues about perhaps why we evolved the complex language that we have, the kinds of societies that our ancestors lived in that led to such a strong selective evolutionary advantage to having more and more complex communication.
Can you tell us a bit about the science of interpreting animal communications over time? I guess maybe, I guess there was a big understanding with Darwin, but a lot before that, I guess, too. And I'm just wondering, like, how is technology now changing it? I understand that technology now could be used um, to trace patterns in animal communications.
Yeah, so animal studying animal communication has gone through some ups and downs. It's true over the years, and really until I guess 70 years ago, it wasn't a subject that was taken very seriously. I mean, animals were considered to be automata with reflexive responses, really with no cognitive background other than just reflexes that responded to certain stimuli. And technology has really helped to move that along because, I mean, apart from the intellectual leap that was made in the first half of the last century, where people started thinking, wait, hang on a moment, these animals evolved in the wild, right? They evolved to respond to a rich and diverse environment. So presumably they have thought processes that help them to deal with that. But then technology has given us a huge leap. I mean, our ability now to record, process, and analyze the signals from such a wide range of animal species gives us a really deep quantitative depth to our understanding, and we can as you say, we can classify, we can describe, we can quantify and measure different aspects of the sounds that they make, for the sake of argument, sounds, and group them into different categories. So we can say this particular bird has this number of different notes. This particular dolphin makes this range of different kinds of whistles, and technology has given us that quantitative tool to start looking at the sounds that animals make and classifying, grouping them into different sets, which gives us the leg up we need to start asking how much information is present.
Mm-hmm. Yeah, I imagine there must be a huge information content in that technological analysis. Is that kind of become a primary tool for you, or is it still a question really of going into the field and observing the animals interacting with each other, or a combination of both?
So the technological side is absolutely indispensable. We really need the ability to quantify, and with some of the new tools, some of the new AI tools that are available with deep neural networks and different machine learning tools, give us the ability to process the data we've already collected and to pull out really useful and interesting nuggets from that information. However, it's all fairly useless unless you're in the field observing these animals, because you have to know what they're doing. If you don't know what they're doing when they're making these sounds, it's very difficult to draw any conclusion about what those sounds mean. Are two individuals interacting in a positive way or a negative way? Are they competing? Are they cooperating? Are they cooperating to hunt? Are they fighting over food? There's so many different possibilities. And when you think about our communication, if you were just to hear, I don't know, this podcast on another planet without any context at all, it would not be possible to understand what was going on. You need that context. You need to be able to see what's happening. And I think this is perhaps one of the areas in which people's expectations are a little too high. And we can't really understand what's going on with animals just by analyzing their sounds. You've got to get out there and you've got to see what they're doing. Preferably perform experiments, present them with different stimuli and see how they respond. But at the very least, to observe the animals in the wild and see them behaving in the wild.
Wondering if there's been any different dialects observed among animal communities, like human communities. I mean, we have different ways of communicating. I guess we're all humans, but based on our individual environments, is there any sort of dialect or something environment specific that the same species would communicate in a slightly different way?
There's very strong evidence for dialects in many species. It's quite easy to show, and one of the explanation for it is quite straightforward, right? If you learn the sounds that you make, you learn from what you hear around you, then there will be a divergence as you get further and further away from any other individual. So if you imagine a group of animals strung out in a line, so like in a long line, and each animal only hears the two neighbors or the neighbors on either side. Well, it should be clear that as you sort of move further and further away from any one individual animal, the communication, the sounds that they learn are going to become more and more different, just through sort of chance and making mistakes and innovating and so on. And you see this in many different species, that as you increase geographical separation, you increase the difference in between the communication systems. Now, we think of dialects as being things like, for instance, different idioms for different concepts. That's not what's happening. This is more accents. It's more like having a range of accents across space. So we can't rule out that there are idiomatic differences between these animals. That's a little bit harder to prove.
Hmm. I wonder what you think about, and I imagine maybe you address this in your new book, about, just, I guess there's some really truly impressive capabilities of animals that a human can't match. And one that sticks in my mind from your 2021 book, The Zoologist Guide to the Galaxy, I think you mentioned the black-capped chickadee that remembers hundreds of or thousands of locations where it stored food. I can't even remember where I put my cell phone. I'm just wondering, is it possible that the information communicated by some animals might approach, like not equal, but maybe approach the complexities of human information? Like, for example, making abstractions or mental models of reality. Is there any evidence of that? And what do you think? What's the conclusion of your book on that?
Well, the abilities of these impressive abilities, not just of the chickadee, but any animal, any impressive animal ability, whether it's the speed with which a cheetah runs or how long a whale can hold its breath, animals do things better than humans. There's plenty of things animals do better than humans, and a few things that humans do better than animals. And that's just a question of adaptation to a particular niche. And one of the things that's quite striking is that where you have an animal in a very specific niche, a very specific set of environments and interactions in which they live, they will tend to develop very specific adaptations to that environment. Goes without saying. Whereas humans, rather like rats and cockroaches, are very good at being general. And we don't need a particular environment to live in. We don't feed off a single food. We don't live in a single kind of tree. We can live anywhere. And it's those animals with the more general abilities that tend to be less good at what they do. They tend to have less of these sort of superpower skills. So it's not surprising that cheetahs can run fast and whales can hold their breath, and we can't do those things. What we're good at is we're really good at generalizing. Now you can sort of take that very broad description of the difference between a generalist species and a specialist species and apply a similar sort of thing to their communicative abilities and say, well, hang on, if we want to ask ourselves, do any animals have a language like us, for instance? What would that look like if an animal had a language like us? What would we expect to see in that animal's niche? What would we expect to see in that animal's diet, in the way that they interact with other individuals and so on? Why do they need a language? Why have they evolved a language? What was the selective pressure that caused them to evolve a language? And the truth is, we don't see that. We really don't see any other species where you look at them and think, I think that animal would really be served, would really have a big advantage to have a language. So this is a big clue that other species don't communicate as we do. One thing that people often ask is they say, well, how can you be sure? How can you be sure that dolphins or snails or whatever don't speak a language and we just don't understand it? And the answer to that is, of course, we can't be sure, but we don't see any reason why that situation would evolve. These animals have all evolved to be efficient. They've all evolved to have traits they need and not to have traits that they don't need. And we really don't see that. We just don't see other animals that appear to be in a position where they would gain advantage from having a language.
I wanted to ask about the octopus. I think you've written about the octopus, and I think we generally hear that it's maybe among the most intelligent of animals. And I'm wondering how its communication abilities convey intelligence and how that's changing our understanding maybe of intelligence itself.
Humans have a very problematic relationship with the word intelligence. We use it a lot. We rarely define it. And we tend to apply it in inappropriate cases. So number one, all animals are intelligent. It is actually, like communication and movement, part of what it is to be an animal. Animals have evolved to move around, find food, exploit opportunities. Every animal has to have intelligence. Intelligence first evolved, of course, to control movement and to sense the environment. So every animal has that. And now the question is what they use it for. So Animals that might need to crack open a nut will have a kind of intelligence that's good at that. Animals that live in large groups and large societies will have an intelligence that helps them to manage those interactions. These are all intelligences, but we sort of want to condense it down into a single word, which is a problem. Now, when it comes to octopuses, they are intelligent in terms of problem solving. And one of the big definitions of intelligence is problem solving, right? How well you can get food when it's hidden or difficult to get at, or something like that. So they have that intelligence. What they don't have, to as much of an extent as many other species, is social intelligence, because they don't live in large communities with lots of complex interactions between them. So although they may be really good at problem solving, they're perhaps not as good at remembering who their neighbor is and what their neighbor was doing yesterday, and were they friends with their enemy, and so on. These complex social interactions are something that's very characteristic of humans, and is present in some other species, chimpanzees, for instance, dolphins, for instance, and is really absent in others, particularly those that live solitary lives. So we've got to break down this idea of intelligence into the different kinds of tasks that intelligence has evolved to solve, and realize that they really are different phenomena.
That's interesting to imagine. I guess that's the complexity of those social relationships. And I'm just wondering, do the different forms of animal communication on Earth say something fundamental about social relationships between living creatures?
I think they do. I think they very, very much do. And this is largely the point of my book as well. So yeah, you have many species that communicate, perhaps even communicate in a complex way, like songbirds. Birdsong is very complex, but the message is very simple. The message is very simple because it's directed at a single goal, identifying your territory, for instance. Whereas when you have individuals that live in a group, they have a lot to say, they have a lot more to say to each other. Groups, animal groupings are broadly cooperative. There's always competition as well. But if the animals are living together, then there's some sort of cooperative element to that. So they benefit from helping each other, and sometimes that help is in the form of exchanging information. Could be information about a predator that's nearby, could be information about where food is found, could be information about how to achieve some kind of difficult task, either building something or perhaps overthrowing the current dominant animal and taking control of the group. So those kinds of more complex social interactions do seem to be a driver for more complex communication. There's more that needs to be said than just, this is my territory, stay away, I don't even want to talk to you.
I wanted to maybe bring that into the context of your 2021 book, The Zoologist's Guide to the Galaxy: What Animals on Earth Reveal About Aliens and Ourselves. And that really opened my eyes to the incredible variety of life forms and their interactions here on Earth, as well as possibly elsewhere in the universe, as I think you're saying. And so I'm wondering, with powerful new technologies like the James Webb Space Telescope, the Vera Rubin Observatory, I mean, these are all promising to revolutionize our understanding of the universe. I'm just wondering how your profession or your study of zoology, how that whole field of study is maybe changing to adapt to the potential of life elsewhere.
So there is certainly a lot of expectation, a lot of excitement, and a lot of new research being done into what the nature of the mechanism of life might be like on other planets. What kind of chemistries, what kind of energy sources, what different ways of perhaps of reproducing and passing on heritable material, like we use DNA. Maybe there are other things that can be used. That's a big field of research. It's not my field of research, but it is a big field of research, and instruments like James Webb and a lot of other sensing instruments are partially, at least, expected to be able to detect signs of life on other planets, particular chemicals that might be indicative of lifelike processes. But where the zoologists come into it is slightly different. We need to understand that complex life, there could be simple life all across the universe. But if there's complex life, the sort of thing that we would recognize as sort of plants and animals that we have on Earth, where there's complex life, there must be complex interactions between those life forms. There must be a complex ecology. And actually, it's the ecology that drives natural selection, that drives evolution. And I think that the sort of astrobiological community hasn't yet adopted this idea of astroecology, hasn't yet adopted this idea that if we want to understand the evolution of life on other planets, we have to understand the interactions between life forms on other planets. Understandably, because we haven't yet discovered life on other planets, we really have no idea what we're talking about yet. But the fact that we need to think about ecological interactions is starting to gain ground now, because we're going to discover life soon. And when we do, we need to be in a position where we can think, how did that life evolve? Where did it come from? What made it complex? Why has it evolved to accumulate complexity? A tree will not pop out of existence on its own. It evolves from something simpler. So it's that element of how ecological interactions drive complexity, I think, is our next big challenge.
One of the most intriguing things I think about that book is how you tie in concepts of physics, for example, into your own field of study. And I guess it's getting all more interconnected in terms of, as you talk about the ecology, I mean, I think I recall you writing about how an alien animal might be supersonic or adapt to different pressures in the environment. If we were to discover life elsewhere, one of the things I recall you said is that we might recognize it by the way it moves through different medium. What do you think would be the most likely discovery first that we might make in terms of a type of life form? Like, is it something that we could relate to something that we see existing here on Earth, or would it be totally different?
There are a lot of different questions there.
Yeah.
I think the most likely thing for us to discover is very simple life. I think there's still quite a lot of debate about how likely complex life is to evolve. I think it's not clear how many of the billions and billions of planets in our galaxy are physically amenable to complex life. So it seems clear that simple life is going to be is going to be more widespread. I don't know about easier to find necessarily. And it is all very far away. We're not going to, much as I would like to be a zoologist on another planet, it's not going to happen. When our best hope of being able to study up close alien life would be in our own solar system, on the moons of Jupiter or Saturn, something like that. So we don't think we're going to be able to get really detailed information. Even our best sensing devices over the next 50 years will only be able to detect chemicals in planetary atmospheres around other stars, which is tremendous, but it doesn't give us that sort of David Attenborough documentary view of the animals themselves. But to your first question about physics, all life is constrained. Life is all about constraints. Now, those constraints are partially due to the laws of physics. You can't fly if you don't meet those physical constraints for flight, either aerodynamic or hydrodynamic and so on. So there are the constraints of the laws of physics, there are constraints of the laws of chemistry. Reactions need to take place, energy needs to be transferred. People have speculated about life on Titan, the moon of Jupiter. It's so cold there that chemical reactions just take place very slowly. It's hard to imagine how there could be enough time for complex life to evolve because of the speed of chemical reactions. That's a constraint of the laws of chemistry. But there are also constraints of the laws of biology. And this is really where we can expect that alien life, if we ever get to see it, will look familiar, because the constraints of the laws of biology also are the same on Earth as they are on other planets. Life needs energy. If there's a shortage of energy, which there always is, some life will take energy from other life. That's just what predation and parasitism is. These things, these different ways of living, are nothing special about Earth. They're biological constraints of how evolution works. So the big picture of what complex life looks like on other planets will be very similar. It's not to say that they'll be the same color or have the same number of legs and so on, but those biological constraints are still applying just as the physical and chemical ones are.
I mean, that makes sense. I guess if, the laws of physics are the same everywhere in the universe, then I guess life would have to adhere to those laws or be constrained by it. Do we do we think that we might understand more about what the nature of life is, or the origin of life, I guess? Or is the question more or less kind of settled in our minds in terms of what life is? I remember, I think you wrote about Aristotle, for example, classified a whale as a fish because it didn't have legs. I'm just wondering if we have discovered anything startling or interesting about life that we didn't know before, and whether that potential to discover something fundamentally new exists.
Yeah, I think there's been a lot of work, a lot of serious effort by biologists and philosophers and physicists and chemists to come up with a definition of life. I mean, people like definitions. It would be nice to have a definition of life, one that is sufficiently broad that it will encompass any kind of life we encounter, and yet one that's non-trivial. And we've got a pretty good idea of some of the things that are essential for life. So life, first and foremost, life is about self-continuation. So it's about using energy to reduce entropy, technically speaking. So rather than dying and decomposing, life goes on, at least for a while, and it needs energy to do that. It needs energy to fight those forces of decay. So somehow, somewhere, there's got to be this element of using energy to keep yourself alive. It's also thought generally that life should probably be compartmentalized. So it follows from the fact that life uses energy to keep itself alive, that energy probably has to be concentrated into some kind of entity, some kind of body, not a diffuse cloud, just sort of floating around. But the other element of the definition of life, which is often skirted over, but is one of the most important, is that life evolves by natural selection. Because no matter how you define life, if it doesn't evolve by natural selection, it will remain exactly as it was when it was created, whatever that was. However the first life form on Earth looked, it would simply stay that way if it weren't for natural selection. So when we think about life, when we think about life as being anything other than some replicating chemicals, we're talking about an entity that undergoes natural selection and accumulates complexity. And I think these are pretty, this is a pretty reasonably good definition of what life is. It will apply anywhere in the universe. It tells us something interesting. It's not just trivial. And I think we can expect all life to conform to that. Now, you mentioned Aristotle. In Aristotle's defense, I think I said this in the book as well, he wasn't being dumb. When he said a whale is a fish, he knew perfectly well that whales breathe air, just like horses do. He simply chose to classify whales according to a different set of criteria from what we now do. And we only classify life and animals and plants in the way that we do because Charles Darwin understood that all life evolves from a single common ancestor. And so Darwin's innovation was we classify life according to its family history. We classify life according to its ancestors. Do they share a lot of ancestors? Do they share a recent ancestor? They're closely related. Do they share a distant ancestor? They're not as closely related. That was a radical decision at the time. And what becomes interesting, of course, is when we discover life on other planets, we will not be able to apply the Darwinian paradigm because we do not descend from a common ancestor with life on a star 100 light years away. And we'll have to go back to Aristotle's method, and we'll have to say, do they have legs? Do they live in the water? Do they move? Maybe if they move, we should call them animals. Maybe if they stay still and absorb energy from light, we should call them plants. These are discussions that people will argue about, but we will have to reassess how we classify life when we do discover it.
Interesting example, I guess, of the human capacity to generalize and communicate generalizations, I guess, is that classification that we do. I wanted to ask actually, so I think you talked about that concept of the Luca, the last universal common ancestor, which I think, if I understand that theory, as I think maybe you might have just described it, is that all life is kind of exists in these trees or branches of trees, and then it all traces to a single common root. So if that's correct, are you saying that that's not going to prove uh, possible in terms of human life or life through the galaxy? Is that just something that applies to life on Earth?
Well, it's certain, almost certain, that life in another solar system will be completely unrelated to us. We won't share a common ancestor. Life on Earth evolved. There was a last universal common ancestor on Earth, different one from what there would be around a distant star. That much we can be sure about. Can't be quite so sure about life in our solar system, okay? Because we know there's quite a lot of transfer of material between planets and moons in our solar system. So it's more than possible that microbes from one planet could go to another, but that's another story. But so we won't be able to compare our family tree with the family tree on another planet. Whether or not life on another planet has a single universal common ancestor, that's a much harder question to answer. And to be honest, although we're confident that all life on Earth, confident but not sure, that all life on Earth has a single universal common ancestor, we're far from sure that there was only ever one common ancestor on Earth. I mean, it's very likely that life arose multiple times on Earth and the different lineages went extinct except for one. That's quite possible. We don't know. And it's not easy to prove one way or the other. So it is possible that on another planet there's life from different lineages. There are reasons to think that might not be the case, but we don't have enough data to determine one way or another. It seems that on Earth, whatever it was, there was something special about Luca, about our common ancestor, that really sort of swept the board and drove other, if there was other life around at the time, drove all other life extinct, and only the descendants of Luca survived. But whether that's inevitable or not, we don't know.
What do you think? I mean, I think you talk a little bit about science fiction movie presentations of life on different worlds. What do you think the science fiction type of presentations get right about life in the universe versus what they just get wrong?
Well, I think a lot of science fiction, particularly science fiction that's geared up towards monsters, is drawing on our fears of tigers and snakes and so on, and the deeply ingrained ideas we have about life on our planet, and that's fine. I think that a lot of science fiction that focuses on human-like behaviors, empires competing with each other, and so on, draws on our experience of human interactions. And so in that sense, one could argue that the vast majority of science fiction is merely a reflection of our life on Earth, and there's nothing wrong with that. And it's great to take our human existence and to sort of make it seem odd, make it seem different, and use that as a storytelling device. I mean, sort of Harry Potter effect. It's like, yeah, it's a story about wizards, but it's not a story about wizards, right? It's a story about ordinary people and the problems that they have. It's just more fun to do it when you're talking about wizards. However, if I'm right, and the sort of the big picture of evolution, the big generalizations we can make about laws of biology are universal, And it may well be that a lot of these science fiction representations are not that far from the truth. You know, the heroes who go to another planet and fight off deadly snakes and monsters. Well, why shouldn't there be snakes and vicious predators on other planets? There probably should be. Empires clashing and competing for territory and so on. Well, that's another point we could perhaps argue about, but it seems likely that if an alien species reaches a sort of technological level that we have reached, that they will also have been through a competitive colonialist, militarist history, and in that way they may actually be very similar to us. I would like to think that by the time any civilization reaches the technological level of interstellar travel, that they've passed that stage, but we can't be sure.
Hmm. It takes me back to that question of what intelligence is, and I guess do we see signs that um, as you've defined intelligence, you said every animal is intelligent. Does the level of intelligence generally increase over time in response to these natural adaptations, or do we see animals where the capabilities are just kind of remain stagnant? And I'm thinking, life in outside Earth, if it's been around for billions more years than life on Earth has been around for, would it naturally likely be more intelligent as a result of just the passage of time?
I don't think it's really, I don't think it really makes a great deal of scientific sense to say, does intelligence increase or not increase? Because these intelligences are very difficult to compare quantitatively. What I think we can say is that the diversity of intelligence probably increases. We know the diversity of life on our planet has been steadily increasing throughout time, with ups and downs a little bit, but certainly for the last 250 million years, life on planet Earth has been getting more and more and more complex and more and more and more diverse. And together with that, intelligence has also become more and more diverse because there are more niches, there are more different ways for animals to interact, and so different solutions to the problems they're facing. Now, is this something that is typical of other planets, that life will always become more and more and more diverse and more complex? Don't know. Probably is, sort of from theoretical considerations. It's quite likely, at least, that would be the case. And now, if that is the case, you could say, if life has been around on another planet for much longer than on Earth, perhaps it has evolved many more different ways of being intelligent. Couple problems with that. One is that actually life on Earth is pretty old, right? I mean, life on Earth is over 4 billion years old, and people often forget, right, that Earth is 4.5 billion years old. The universe is only 14 billion years old, so that's a big chunk of the life of the universe. So you wouldn't expect to be. There's no other planets that are 10 times as old as the Earth, that's for sure. So it's unlikely that there's life that's billions of years more advanced than us. We do think that life requires second generation stars at least, so you have heavy metals and things like that present. But the other question is, once life reaches a certain technological capability, as we have done, then perhaps the nature of life's relationship to intelligence changes. So obviously, we are only just beginning to leverage our technological abilities, and we're sort of playing around with ideas like artificial intelligence. I mean, we really don't have artificial intelligence in any real sense yet, but we will do eventually. And then when that happens, perhaps we don't need to evolve a greater biological intelligence. Perhaps we just rely on our computers. And we may find that on older civilizations that have been around for longer, or perhaps developed technology much earlier than we did, they may not be much more intelligent than us. They may just have better computers.
It's interesting to imagine, I guess and you talk about that diversity and the increasing range potential of diversity, I guess. One thing that really struck me as interesting in your zoologist guide was I think you talked about the aphid and how it, if I get the story right, it reproduces asexually part of the year and sexually for another part of the year. And so for part of the year, it's mixing its gene pool, increasing its diversity, and for the other part of the year, it's not. It's kind of like cloning itself. Is that do I, if I have that correct, I'm just wondering, does that mean that some animals are capable of selecting the times at which they diversify versus not selecting the times? Or is that function something that's imposed on the aphids externally?
I don't think so. So it's better not to think in terms of imposition and choices, and better to think in terms of what's a what's an effective strategy. So what will serve you better?
Hmm.
And clearly, when times are good, it's great to have lots and lots of offspring, and preferably offspring that are genetically identical to you. And that's a really good strategy. But there are a lot of drawbacks to that strategy. I mean, that really doesn't work long term for most species. So people often ask, like, will aliens have sex? And the answer is yes, they will, because there are theoretical reasons to believe that complex life without something analogous to sex is unlikely to evolve. And what you see with aphids and with creatures that sometimes reproduce sexually, sometimes reproduce asexually, is that this is simply the most effective strategy that they have at their disposal to deal with, for instance, unpredictable environmental conditions. Um, it's not, it shouldn't surprise us, but we also shouldn't we shouldn't read into it that somehow these animals are choosing or making some kind of conscious choice. It's really no different from the fact that we sweat when it is hot and put on clothes when it's cold. It's different ways of adapting to different environmental conditions.
Hmm. I guess I wanted to maybe move to concluding our discussion in terms of just trying to understand what the big upcoming topics are in zoology and how zoology is changing. I mean, we talked about that a little bit earlier in terms of how it's adapting maybe to thinking about life elsewhere. What do you think might be the most exciting or maybe most revolutionary prospect for zoologists and maybe other branches of science that relate to it?
You're asking me. I'm going to answer in my field, whereas there are zoologists, of course, who will disagree and say their field is more exciting. Um, no, I think that some of the big some of the big issues in 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 zoology are clearly around conservation. I mean, we are in a conservation crisis, and um, we really are not coping well with our relationship to the natural world. So there are some big questions that need to be solved about diversity, about how we preserve diversity, and about what diversity means. What is worth preserving and what isn't. We don't have a good enough understanding of the natural world to be able to do that at the moment. I mean, even just in my field, when you think about animal communication, there are so many different forms of communication. There are even, as you mentioned earlier, animals with different dialects. Do we need to preserve the dialects? Where is the conservation priorities for all of these species? So that's a very immediate issue. I do think that um, there's a lot of potential for major breakthroughs in terms of understanding animal cognition and understanding the relationships of the mental processes that the animals go through, and their relationships to their social interactions. I think we can expect to see major developments there. And let's be honest, understanding the communication is a part of that. I won't say translate. I don't think translate is the correct word, but I do think that we will see a lot of progress there. And then there are evolutionary questions that we're always approaching and never seem to be getting near to the end of those questions. Why is there the diversity that there is? I said that life has been becoming more complex and more diverse on Earth for the last 250 million years. Why just for the last 250 million years? What can we use that as some sort of indicator of what life might be like on other planets? There's a lot of understanding of how life became as complex as it is today that it's just missing at the moment, and we really need to fill in those gaps.
What is it that you're hoping the reader of your new book, Why Animals Talk, will take away from this? I guess I just heard an ecological message in terms of understanding what we're doing to the world, I guess maybe by understanding how that's affecting animal communications and behavior. What are the main, like what's the main driver for, like, you started by saying you're not talking, the main purpose of the book isn't to say how animals communicate. You said it's why they communicate. As we understand the why question, what do you think that will do? And if that question is far more broadly understood, I think now than it is, what do you think the results will be? What do you hope will happen?
I really want people to appreciate animal communication and the animals who are communicating for what they are. And there's a tendency for people to divide along a single dividing line. Either animals are dumb and don't talk, or they talk like us. And neither of those are helpful, realistic, or appealing descriptions of animal life. There are thousands of species of animals in the world, and each one communicates differently. And if we try and lump them all together, we're really doing them a disservice. When we see dolphins, birds, monkeys, and say they're talking just like we are, we're doing them a disservice. It makes much more sense to understand why they communicate the way they do, what need they have to communicate, what is it about their life, what is it about their environment that drives the kind of communication that they have. And only by doing that can we really understand them and really appreciate them. And it's difficult. It's difficult. I understand that it is, because we so rarely see these animals in the wild. We so rarely see them interacting in the way that they've evolved to interact with each other and with their environment. It's difficult. I mean, it's easy to say, well, they're like us. They're making a lot of noise. They must be just like us. When you see them out in the wild doing what they need to do, what they've evolved to do, then you get a proper picture of what these animals are, why they are the way that they are. And I think that kind of appreciation of the true nature of the uniqueness of each of these animal species, they don't need to be like us, right? What conceit is that these animals should be like us? Let's appreciate them for what they really are.
Hmm. And I think that's, one of the huge benefits of the work that you do is you bring that world to us that, most of us locked in cities will never see. And it really is fascinating to imagine this whole realm of communication, this whole realm of information that we just simply assume never happens, but it's out there happening. And there's this huge, I mean, we're a society that lives in big data, and there's a huge amount of data out there that is yet to be understood. And I think that could just open potentially huge new frontiers, I guess, to explore and understand.
Yeah, and I do appreciate that. I'm unfairly lucky to be able to observe these animals and to be with them in the wild, and I do hope that some of what I do brings some of that home to the readers. But we don't live in isolation from animals. None of us do, and actually just appreciating what is around us is a very easy skill. If it's anything from the birds at your bird feeder, urban foxes, rabbits, take the time and observe these animals for what they're doing, what they're actually doing. You'll see a lot of communication goes on there, a lot of communication. body posture, subtle movements of ears or paws. This is a skill that I would love everyone to cultivate. It really does give a different perspective on the world.
Mhm. Indeed. Well, thank you so much for talking to us about this, and I'm really looking forward to Why Animals Talk when it comes out in August. I think it definitely it could definitely open my eyes even more than the zoologist guide did. So you brought a lot more appreciation, I think, for the natural world, and just because animals are adapting to it, we adapt to it as well. So I think it learning how animals adapt tells us more about how our own adaptation and the adaptations we will need to make. So I think that's really interesting and really looking forward to your book. So thank you for taking the time.
Thank you. No, had a great time.
It's been great speaking to you. Thank you. Our thanks go to today's guest and to you for listening to the Quantum Feedback Loop. Please subscribe to this podcast wherever you get your podcasts. And don't forget to check out the Quantum Record at thequantumrecord.com. The Quantum Record is a monthly journal of philosophy, science, technology, and time, where you'll find the latest developments in our rapidly evolving technological world.